Find the exact values for the 6 trigonometric functions of the angle theta in each figure. Rationalize the denominator where necessary. You need to remember what the trig functions are equal to. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And remember, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. The reciprocal functions for each of these, cotangent of theta would be adjacent over opposite. Secant of theta would be hypotenuse over adjacent. And cosecant of theta is equal to hypotenuse over opposite. So let's figure out what we know. We know 2 sides. We need to figure out my third side. So to figure out the third side, remember that a leg squared plus a leg squared is equal to the hypotenuse squared. So plus. So 36 plus 64 is equal to c squared. 100 is equal to c squared. So 10 is what c is equal to. So now just plug in what you know. My angle theta is here. This is my opposite side. This is my hypotenuse. And this is my adjacent side. So the sine is opposite over hypotenuse, which reduces to 3/5. 3 over 5. Cosine is adjacent, which is 8, over hypotenuse, which is 10, which reduces to 4/5. Tangent is my opposite, which is 6, over my adjacent, which is 8, which reduces to 3/4. Cosecant is the reciprocal of sine, so that would be 3/5, or I'm sorry, 5/3, because sine was 3/5. Cosine and secant are reciprocals, so 5/4, and cotangent and tangent are reciprocals. Next one, find my missing side. And again, this is my opposite side. This is my hypotenuse. I need to find the adjacent side. I know that the hypotenuse squared is equal to a leg squared plus a leg squared. So 12 squared is 144 is equal to 16 plus a squared. 144 minus 16 is equal to a squared. 114 minus 16 gives me 128 is a squared. And I know that 128, when I take the square root of 128 is 2 times 64. Square root of 64 is 8. So this is 8 radical 2. So that's what my adjacent side is equal to. So now, all I have to do is plug in what I know. So my sine of an angle so the sine of theta is opposite over hypotenuse, which reduces to 1 over 3. The cosine of an angle is my adjacent side, 8 radical 2 over my hypotenuse, which reduces to 2 radical tangent of theta is opposite over my adjacent, which reduces to 1 over 2 radical 2, rationalize the denominator, and I end up with radical 2 over 4. Sine and cosecant are reciprocals, so then I get 3 over 1 is 3 for cosecant. Cosine and secant are reciprocals, so my secant, I have enough room, so the secant of theta is the reciprocal of 2 radical 2 over 3, so it's 3 over 2 radical 2. Rationalize the denominator, and I end up with 3 radical 2 over 4. And tangent and cotangent are reciprocals, so what I would do is look right there. The reciprocal of that is my cotangent function, which is 2 radical 2 over 1. 14. Use reciprocal and quotient identities to find the tangent, cosecant, secant, and cotangent. So I know that sine is 8 over 12 or 17. So let me draw a picture. That's my angle. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So now I have my triangle written out, and now it's just like what we did before, except I have all 3 sides, so I can read what I know. So sine is 8/17. Cosecant of theta is the reciprocal of that. Cosine is 15/17. So secant of theta is the reciprocal of that. Tangent of an angle. Remember, tangent also is equal to, besides TOA, opposite over adjacent, it's also equal to sine over cosine. But I could just do it, if I want, opposite over adjacent, which is 8 over 15. And cotangent is the reciprocal of that, 15 over 8. I'm not going to do the whole thing for you here, but I'm just going to tell you that use the given trigonometric function. Or actually, I will do this whole one. I'm going to do the next one. Cotangent. Right angle. Cotangent. Remember, it's a reciprocal of tangent. And tangent's opposite over adjacent. So this is adjacent over opposite. So if that's my angle theta, my opposite is 11, my adjacent is 6. To find my missing side, a squared plus b squared is equal to c squared. So when I do that, 11 squared plus 6 squared is equal to my hypotenuse squared. 11 squared is 121, and 6 squared is 36. This is 157 is equal to h squared. So my hypotenuse is equal to the square root of 157. So now let's try to find the trig function. It's 57. Sine of theta is 11 over radical 157. Rationalize the denominator, and I get 11 radical 157 over 157. Cosecant of my angle is the reciprocal of sine. So that's radical 157 over 11. Cosine of theta is equal to the adjacent over the hypotenuse, which ends up to be 6 radical 157 over 157. the secant of my angle is equal to radical 157 over 6. It's a reciprocal of cosine. Cotangent is 6 over 11, so tangent is a reciprocal, 11 over 6. This is the one that I'm not going to do the whole problem for you. But just remember that 4 is equal to 4 over 1. So if I was drawing my picture, remember cosecant and sine are reciprocals. So this is hypotenuse over opposite. So my hypotenuse is 4 and my opposite is 1. And I'll let you finish it, find your missing side. 26. Given that cosine of 37 is equal to 0.7986 and find sine of 53. 53 and 37 are complements of each other. So the cosine of 37 degrees is equal to the sine of 53. So the sine of 53 is just equal to 0.7986. Again, complementary relationships, secant and cosecant. So the secant of 12 is equal to the cosecant of 78. So it's equal to 1.0223. Use the table in 5.1 and simplify the resulting expression. The table in 5.1 is the table that we came with those special triangles. So remember, if that's 60 degrees, there's my right angle. This is a 1, 2, radical 3 triangle. 45 degrees would be 1, 1, radical 2. So you don't even need to use the table. Just draw your triangles and let's look at what you have. So the sine of 60 is opposite, radical 3, over hypotenuse. The cosine of 45 is 1 over radical 2. The cosine of 60 is 1 over 2. And the sine of 45 is 1 over radical 2. So I end up with radical 3 plus 1 over 2 radical 2. Rationalize the denominator. I end up with radical 6 plus radical 2 all over 4. And we're done here. Next one, draw my triangles again. Right triangle, that's a 30-degree triangle. 1, 2, radical 3 on my sides. 45, 1, 1, radical 2. So radical 2. 2. So sine of 30 is opposite over hypotenuse, 1/2. Cosine of 45 is 1 over radical 2. Plus cosine of 30 is radical 3 over 2. Sine of 45 is 1 over radical 2. So 1 plus radical 3 over 2 radical 2. Rationalize the denominator, and I end up with radical 2 plus radical 6 over 4. Use the figure below and the given values to find each specified side length and trigonometric function value. Round your answers to 3 decimal places. So when I use this picture here, A is 19. B, whoops, is 27. So 19, 27. So if I want to find C, I would take the square root of 27 squared plus 19 squared. And you'll get about 33.015. What I like to do when I'm using my calculator is store this number somewhere so I don't have to retype the number. Or you can use the arrows if you have the newer calculators and grab it. To store it, there's a button off to the left. It's between the 1 and the 4 to the left. It's STO. So you could do store And then you could store it in any letter you want. See how the letters are green, A, B, C, D, and whatever you want to put it in? You can store it somewhere. So you just hit the alpha and then the letter, and it'll store it there. And then you can recall it anytime you need to use it. So the cosine of an angle would be my adjacent side. Cosine of an angle is adjacent over the hypotenuse. The adjacent side is 27, and the hypotenuse is at 33.015, etc. So I could do 27, and then you could divide, and then if you stored it somewhere, you could do the alpha and then the letter you stored it in. So that way you're not retyping the letter, and you get approximately 0.818 when you plug it into your calculator. Next one, 44. Your angle is 30 degrees, and A is 5. I'm going to do this two ways, one with a calculator and one without the calculator. First, I'm going to do this without this calculator. Without the calculator, I know that the ratio of my sides, and this is my opposite side, this is my adjacent side, and this is my hypotenuse. So I know in a 30-degree triangle that I have hypotenuse, adjacent, and hypotenuse. Opposite. The opposite of 30 is 1. The hypotenuse is 2, and the adjacent is radical 3. It has the sides have a ratio of 1 for that opposite, 2 for the hypotenuse, and 3 for the adjacent side. If my opposite side here is 5, then all I have to do, if I multiply 1 by 5, I get 5. If I multiply radical 3 by 5, I get my adjacent side. And if I multiply 2 by the hypotenuse, I get my hypotenuse side, or by 5. So this will have a ratio of 5, 5 radical 3, and 10. So my opposite side is 5. My adjacent side is 5 radical 3, and my hypotenuse is 10. Hypotenuse was C, I found it. The adjacent was D, and that's what I needed to do. Okay. Another way you could use your calculator, and you know that the sine of 30 degrees is equal to opposite over my hypotenuse. And then you could solve it. Sine of 30 is a half. You don't even need the calculator to do it. You could do it this way too. Cross multiply, hypotenuse is equal to 10. So there I have my hypotenuse. If I want to find my adjacent side, I would probably do the cosine of 30 degrees. And the cosine of 30 degrees is my adjacent side over my hypotenuse. Or I could use the tangent of 30 degrees and get opposite over adjacent. Either one, whatever you want to do. So I think I will do the tangent if I was going to do tangent. So the tangent of 30 degrees, remember, is 1, 2, radical 3 is a triangle. So the opposite of 30 is 1, and the adjacent side would be radical 3. That is equal to 5 over my adjacent side. And then when I cross multiply, I get A is equal to 5 radical 3. So either way you do it, it does work. 48. Now you have to round to 3 decimal places, so you definitely need your calculator for this one. A is 6.2. C is 18.7. So if I want to find B, I know that 18.7 squared is equal to 6.2 squared plus B squared. So 18.7 squared minus 6.2 squared is equal to B squared, and take the square root. So to get B, pick up your calculator and take the square root of 18.7 squared minus and you get approximately, I should do that, approximately equal to 17.64. And that's what B is. And like I said, if you want to, you can store it. You don't have to, but I would recommend you do that way you won't have a rounding error. I would always try to grab it because if not, so you don't get a rounding error, you'd have to type in the whole number, that 17.64227876, what you got in your calculator. So I would store that somewhere. So when you need to use it, you can use it again. So secant, remember secant and cosine are reciprocals of each other. So secant would be hypotenuse over my adjacent side. So my hypotenuse is 18.7, and my adjacent side is the number that I just came up with at 17.64. So 18.7 divided by the 17.64, and you'll get approximately 1.06. You get 1.0599537776. So there's secant. Cotangent of theta is a reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is my adjacent side, which is B, over my opposite, which is 6.2. So if I take my B that you just got, which is 17.64, and I divide by 6.2, I would get approximately, for cotangent, 2.845, so 85. 52. Use the given function values of the acute angle theta and find the indicated trigonometric functions. If the cosecant of theta is equal to 2, which is really 2 over 1, you draw my triangle. Makes it a lot easier, I think. Remember, cosecant and sine are reciprocals. So sine is opposite over hypotenuse. Cosecant would be hypotenuse over opposite. And I hope you recognize that right away. 1, 2, third side's radical 3. If you don't, you can use Pythagorean theorem. A side squared plus a side squared equals a hypotenuse squared. So 4 squared, or 2 squared, which is 4, minus 1 squared. So 4 minus 1 is 3, and then you take the square root. So you get radical 3. So now, when you do sine of an angle, sine's easy. You already had all the information from here. Reciprocal. Cosine, look at your picture. Adjacent over hypotenuse. Tangent of theta, look at your picture. Opposite over adjacent. When you rationalize the denominator, you have radical 3 over 3. And tangent of 90 minus theta is the same thing as the cotangent of theta. So if you want, you can just look at the cotangent of theta, and that's radical 3 over 1, which is radical 3. Cotangent is equal to 3 halves. So my cotangent is the reciprocal of tangent. Tangent's opposite over, whoops, got the wrong numbers there. Tangent is opposite over adjacent, TOA. So cotangent is reciprocal of that. So that would be adjacent over the opposite. So tangent is just reciprocal of what was given. So 3 halves, 2 over 3. Let's find my missing side. This missing side would be 3 squared plus 2 squared, and then take the square root. 9 plus 4 is 13, so it's the square root of 13. So cosecant of an angle is cosecant and tangent sine are reciprocals. So it's the hypotenuse over the opposite. Sine of theta is opposite over hypotenuse. Rationalize the denominator. I have 2 radical 13 over 13. And sine of 90 minus theta is the same as the cosine of theta. And the cosine is adjacent over hypotenuse. Rationalize the denominator. You have 3 radical 13 over 13. I'm going to do the rest in another part. So I will have a second part and a third part to this.